Continuing with the quadratic functions. Now, let us understand the next idea, which I'm taking actually from the other playlist that we have been doing, that is on the domain and range of the function. So using that concept, if you have not seen those videos, I suggest that you go and see the domain and range videos of the functions that have in the second playlist. But using the ideas, what we do is we look at the behavior of all these quadratic functions now and also relate with what we did previously in the quadratic function. That is, we were able to write the completed square form of the quadratic function. So let us look at the interrelation between the completed the square form and how can we then comment about the behavior of a quadratic function. So let us look at all these questions and see what can we say about different parts here. If I look at part A, y is equal to x square. And if I compare with the completed square form that I have given here, the vertex at h comma k, then we can see that the vertex is 0, 0. And because y is equal to x square, therefore y is always going to be 0 or more than 0. If x is 0, then y would be 0, or for any other value of x, y is to be greater than equal to 0. For the B part, y is minus of x squared. So vertex is still 0, 0. And here we are going to get y as either 0 or minus 0 because y is negative of a positive number. X square is positive, y is negative of x square. Right? So the entire graph is going to be either on the touching the x-axis or going to be below the x-axis. That means all the y values equal to 0 or less than 0. Going on to the third part, we have y is equal to x squared plus 2. So here we don't need to do any completed the square form because there is no x term here. When the x term is not there, it is better to not convert it into the completed the square form, and we can directly comment on the behavior of this function. X square we know is always 0 or more than 0. So y will be greater than equal to 2. Is that right? And the vertex is still going to be equal to 0, 2. Right? Vertex is 0, 2, which is an x square coefficient is positive. So it's going to be a minimum point. And this is the coordinates of the vertex. Now moving on to the next part, that is the part D, where we have y equal to negative 2x plus 3 whole square. Y is equal to negative 2x plus 3 whole square, and therefore x plus 3 whole square is always going to be either 0 or more than 0. When x is minus 3, then x plus 3 whole square will be 0, otherwise it will be positive. And therefore, because y is multiplying with negative 2 with a positive value, y is going to be less than equal to 0. Right? And the coordinates of the vertex are going to be negative 3, 0. We are not adding anything here. Nothing is being added. Therefore, the k value is 0. And it's x plus 3, which means x minus of minus 3. So if we compare with the completed square form, the h here is negative 3, which is the x coordinate of the vertex. And if you see, there's a minus 2. So the graph of this function is going to be like that. And the maximum value of the function is going to be 0. And that happens at minus 3, 0. So it's a parabola opening downwards. That is how we look at the various functions. And this type of information that we get from the completed the square form or without that is very useful to find out the range of the functions and also to say a lot of things about the vertex, the sketch of the function and everything. Now moving on to the E part, we can do here only 1 minus x minus 2 whole square. Now x minus 2 whole square is always greater than equal to 0. Therefore, y is going to be less than equal to 1. I am subtracting a positive value or 0 from 1. So if it is 0, then y would be 1 minus 0, which is 1. And if it's going to be positive, then y is going to be 1 minus a positive number. That means y is going to become smaller than 1. So the y is going to be less than equal to 1, and the vertex is going to be. Now we have both the h and the k, and the vertex is going to be 2, 1. because this can also be written as negative of x minus 2 whole square plus 1, which means the vertex is 2, 1, and the parabola is again going to be like this with the vertex has 2, 1, so the maximum value of the function is 1, and happens when x is 2. So that is how one can look at different forms and then be able to work out. Now, if I'm not doing the f part here, of course, one can expand this and look at the, now looking at the g, the h, and the I, they are not in the completed square form. And therefore, one should be able to convert that to the form that we have already discussed, how to convert this function to the completed square form, and then we can say about the vertex, we can say about the range of the function, we can also sketch the graph, and also tell whether it's a maximum point or a minimum point. So let us do one of the questions here. Let's do h. So if I look at h, or let me do maybe I, let's do I, because the coefficient of x square is not just 1, it's minus 3. So if I do I part, then it's going to be minus 3x squared plus fx, for which negative 3 can be factored out, and we'll be left with x squared minus 5 over 3x. Remember, we have to get plus 5x. So minus 5 by 3x into minus 3 would make it plus 5x. And now you can convert that into x minus 5 by 3 half is 5 by 6. Right? 5 by 6 whole square. And then you do minus of 5 by 6 whole square within the completed bracket. And then one can expand that and then comment on the maximum and minimum value of the function. Right? So if you have any doubts, you can comment on the video. And if any particular part is not clear, you can ask me to make that thing very clear, and I can include that in the next video. So it's very important that we understand that the completed the square form is the main thing in quadratics. Of course, there are other things also, and there are other ways of analyzing the quadratic functions, like using the discriminant and other things that we'll see in the subsequent videos. But if you look at the function of a quadratic, look at a quadratic function and look at the domain, the range, comment on the behavior of the function, it's important to convert it into a completed the square form. Thank you very much.